Hello, math students. We are going to finally move away from graphing systems of equations. Graphing systems is really nice. It gives us a visual. We know how to graph. You can see what's really going on. However, graphing isn't nice if you don't get a whole number kind of an answer, or if you get really, really big or really, really small numbers that would be hard to see on a normal sized graph that you normally have. So we have other ways to solve systems. Substitution is the next way that we're going to use this. And you've actually used substitution anytime you check an answer by putting your answer back into the original equation. That's substitution. So today, substitution is replacing one variable so that there's only one variable instead of having x's and y's, for instance. Okay, so if I'm looking at this, I've got these steps that probably don't make a whole lot of sense until we do a problem. But we're going to take one of the equations and make sure that we've got a variable all by itself. Today, this step will be done for you. In the next lesson, you're going to have to do a little bit of work for that. Once we know an answer from step one, when we have a variable that's already by itself, so let's say like y equals 7, we will substitute that into the other equation so we can figure out what the x is equal to. And then once we know the x and the y, then we can go ahead and write the ordered pair for the solution. So here's an example. I've got two equations, and they're pretty basic, pretty easy equations. Y equals x plus 5 and y equals 8. Here's what a really simple substitution looks like. Typically, when I have these kind of problems, I start by saying, this is what my y is equal to. I'm going to put that instead of, I'm going to substitute it in place of the y. So I have that done right here. I took the y out, and I put the 8 in its place. Now this we can solve because there's only one variable, right? So we could subtract 5, and you are going to get that x equals 3. Now I know what the x is. I knew from the beginning of this problem what the y was. The y was equal to 8. So I can write that as an ordered pair. Make sure you put your x first. You can check this by graphing. It takes a while. It's not a reasonable thing for me to ask you to solve it and then also graph it to check it. But that's how we can see a visual just in case you want to see that this works. If you graph those two lines, the first one was that horizontal line just at y equals 8. The second one is at y equals x plus 5, 1x plus 5. It does cross at 3, 8, which would be right there. In this example, it's a little bit more complicated because I don't have just y equals a number. In this problem, the y is equal to x plus 3. So again, what I said in the last slide is when I do these kind of problems, I would take this y equals, and I put a box around it. That's why I've got it drawn on there also. That's what the y is. That is going to go right here instead of the y. It's going to take the place of the y. So I'll have x plus the stuff that I get instead of the y is that x plus 3 equals 25. So I took the y out, I put x plus 3 in its place. But now you can absolutely handle the rest of this math, right? We can combine these x's. I had a 1x and another 1x gives me a 2x. And then I could subtract 3 from both of those. And that's how I get that 2x equals 22. I'm just going to show this division right there quickly because then I can find out that x is 11. Once I know what the x is, I still do need to find the y. And the issue is that since I don't just have y equals a number like I did in the last problem, I have to take that 11 and I'm going to put that number into that equation that I have right there with the red box around the stuff. But I'm going to say, I know that x is 11. I'm going to put the 11 right there. So if x is 11, then I could say that y is equal to 11 plus 3, which gives us 14. So I know the x was 11, the y was 14. There's my solution. So I would suggest that you write these example problems down. You're going to need some practice. None of the math is that difficult, but we do need to practice this because it is going to feel a little uncomfortable at first. This one's really nice and easy. These first three actually are all really nice and easy because I'm telling you y equals a number. I'm giving you half of the answer, half of the ordered pair. Y is 1. That is what I'm going to put instead of the y. So I'll have 1 equals 6 plus x. I can solve that. So x is -5. The y was already 1. That means -5 is x, y is 1. There's my solution. In number 2, this time the y is equal to 12. So I'm going to take this 12. I'm going to put it in place of that y. And a lot of people want to jump to like, oh, it's going to be 5, right? Because 7 and 5 is 12, but that's not really what's happening in this problem. If I get rid of my 7, I have 5 equals -1x. X is actually -5. So I knew the x was -5. I already knew that the y was 12, so this is going to be -5, 12. In the third problem, the y is 21. I'm going to put that instead of the y. So I'll have x equals 3, and then instead of a y, I'm going to say 21. This one's a little easier actually to solve. X is going to be 63. And again, I already knew that the y was going to be 21, so my ordered pair is 63 and 21. In these two problems, not quite as obvious now. Number 4, both equations are y equals. Sorry for the bell. This is what the y is equal to. I'm going to put it in place of that y. Doesn't matter which one of the two y's you use, by the way. So I would have x plus 1 instead of the y equals 2x minus 1. And now I can solve this. I can get rid of the 1x. And feel free to pause it if I'm solving this too quickly. And then I would add 1. I don't even need to write 1x. That's just x is 2. But again, as I said before, now that y wasn't just a number, now I have to actually do some math to figure out what the y is going to be equal to. So if I use that top equation, the equation just said y equals x plus 1. I'm going to put this instead of that x. So the y is 3. The x was 2, right? 2, 3. You can absolutely substitute it back into either equation to check that. I just used the top equation. So if I use the bottom equation, 2 times the 2 for the x would be 4, minus 1 would be 3 for the y. And number 5. This time instead of y being by itself, I've got an x by itself. That's okay. That is what the x is equal to. That's going to go instead of the x. So I'll have, let me do a 2-color thing here. Instead of the x, now notice I'm using parentheses. Anytime you're going to need some distribution, absolutely use parentheses. In fact, I would even say just always use parentheses when you substitute if there's anything else on that side of the equal sign. So this is going to give me -2y plus 16 plus 6y equals 28. If I combine my y's, that's a 4y. And then we'll get rid of the 16. Again, I know I'm solving this kind of quickly, but we are good at solving equations now. So then y is going to be 3. I still have to find the x. The y is 3, but if I use this top equation, then x will be equal to -y, so -3 plus 8, which is going to be 5. So my ordered pair, the x is 5, the y is 3. on these last problems. The top equation has the y all by itself. This will go in place of the y. Again, I'm going to do both of these problems very quickly. Feel free to pause and try the problems on your own if you want to. So I'm going to have negative x plus 3, and then instead of a y, that's what my y was, equals negative 9. So I just took the y out, I put the stuff in place of the y. That'll be a negative 7x. And then when I subtract the 12, I have that negative 7x equals negative 21. So the x is going to be equal to 3. If the x is 3, then using this equation right here.
Please excuse this quick interruption. A reminder to our 7th grade students with last names Obst, OBST, to Schneider. Obst to Schneider, please be in the library for your math session 2 board exam. We'll see you there.
I'm so sorry for that interruption. Again, in addition to all the bells, there's my ordered pair. And for the last one, this time I know what the x is. This goes in place of the x. I know that 3/4 can kind of throw some people off, but I'll have 3/4. It's kind of hard to read 3 there. And then instead of the x, I would put this. And then here's the rest of the equation. That'll be a negative because they're different signs. 3/4 of 4 is just 3. Check it with the calculator if you don't believe me, or show the work over here. 3/4 times 4 over 1, that's equal to 3. Plus 3/4 of 12 would be 9. So I'm going to combine my y's, and again, I'm going to work a little bit of magic and get rid of this 9 at the same time. So I'll have negative 8y equals negative 2. Dividing by negative 8, I know that some people see this and they start to freak out and think they did something wrong. But a negative over a negative will be positive. 2 over 8 is going to be 1/4. That's what the y is equal to. To find the x, I would use this equation where the x is all by itself. I'm going to, I guess, kind of bring that up here. The x will be negative 4 times positive 1/4 plus 12. Negative 1/4, or negative 4 times 1/4 would be negative 1. Oh, plus 12, I was jumping to the answer already there, is going to be 11. So this ordered pair would be 11 and 1/4. I kept one in there that had a fraction because that's going to happen today. Oh, maybe not today, actually, on the next assignment, I think. So today, we've got a worksheet about solving systems with substitution. I just want you to do the odds. The entire worksheet is a little bit too long. The entire answer key is in Schoology, so feel free to do extra problems if you want to practice more, but there'll be a learning tech for you in Schoology as well. Let me know if you need any help.